Sorry for the inconvenience. Due to the first video, I have some problem in it, so I have done another video. Hope you like it. Welcome to my channel. Today I am going to discuss about the presentation on optical fibers. I have done these many topics, that is defining the optical fiber, principles, structure and types of optical fibers, advantages and disadvantages of optical fibers, applications of optical fibers, and last but not the least, the conclusion part, which is very interesting. And let us go. First part is defining the optical fiber. Optical fiber is a transparent dielectric and able to guide the visible and infrared light over a long distance. The guiding media to the light is called as an optical fiber. I think optical fiber is hair-like structure which is used to transmit the light for a long distance without the loss of a fraction of energy, and the guiding media to the light is called as an optical fiber. Here the optical fiber obeys the laws of conservation of energy. I will say in the next slide how it obeys. Here in first figure you can see here this is the normal picture of an optical fibers. In second figure, the bundle of optical fibers, or we can say the collection of optical fibers, is called as an the cable. And next, the principle, the physical principle based on which the optical fiber is total internal reflection. When the angle of incidence exceeds the critical angle, then the light is reflected back into the same media. Here, before going to the total internal reflection, let us recall what is refraction. Refraction is nothing but the bending of light from denser to rarer media is called as an refraction. Then, when the angle of incidence is just greater than critical angle, then it is called just critical angle. When it is greater than just critical angle, then it gets totally reflected back into the same media. It means that you can see there is no refraction only. There is only the reflection, that is the phenomena which is called as a total internal reflection. I will show in next slide, which is very clear. Here you can see where the core is of higher refractive index, that is of 1.7, and clad is of lesser refractive index of 1.5. This is how the refractive index varies from core to clad. And you can see the total internal reflection, how it takes place. When the angle of incidence is just greater than the critical angle, then the total internal reflection takes place. Next, in this figure you can clearly observe how the total internal reflection takes place. I said you what is refraction. The bending of light from denser to rarer media is called as an refraction. You can see here how the bending of light from denser to rarer media takes place. And still one I forgot to tell, there are mainly two conditions, means there are two conditions for which the total internal reflection is applicable. Only if the two conditions are obeyed, then only the total internal reflection takes place, or else it doesn't take place. And that two conditions are, first condition is the light must travel from denser to rarer media. Okay na? That is, the angle of incidence must be greater than the critical angle. Then only the total internal reflection takes place, or else it doesn't take place. Here, as I said you, in first figure we have seen the refraction, and in second figure here the angle of incidence is just equal to the critical angle. Then it just grazes, or you can say it is on the boundary of optical fiber. It is nearer to optical fiber. When the angle of incidence exceeds the critical angle, then the total internal reflection takes place. You can see, you can observe. It means that there is no refraction only, and the refraction phenomena goes out here, and the light is totally internal reflected here. So that is called as an total internal reflection. And example for the total internal reflection I can say that is mirage. You can go through the in detail in another video. I will explain. If you want, I will do another video on total internal reflection. Next, the structure of optical fiber. Optical fiber, the core. Here, as I said you, the core is of high refractive index and it is made up of 8 micrometer, means 8 micrometer of diameter, and clad, which is of 125 micrometer of diameter. And here the buffer, which holds both core and clad, and the jacket, which holds more than one optical fiber. Here the core carries the signal, whereas the clad keeps the light in the core, and buffer, which protects the core and clad from the damage and the moisture, or we can say from any disturbance from the atmosphere or from the environment, and the jacket, which holds more than one fiber. Next is types of optical fibers. Here the types of optical fibers have a certain more details, but in this video I am describing in a short. Material used here, the glass fiber. The glass fiber is used for glass fiber has many applications, and these glass fibers are made up of silicon, and these plastic fibers, which are mainly used for decoration purpose. And this on basis on mode of transmission, we can divide two types, that is single mode and multi mode. When the optical fibers allows only the single mode signals to transmit, so then it is called as a single mode optical fiber. If it allows more than multi mode, then it is called as a multi mode optical fiber. And on the basis of refractive index, it is also divided into two types, that is step index refractive index and graded index refractive index. In step index refractive index, the refractive index decreases step by step, and in graded index optical fiber, the core is of non-uniform refractive index. Okay, na? So here this is how the types of optical fibers are classified. And next comes the advantages of optical fiber. Advantages of optical fiber: first is resource conservation. You know that glass is made up of silicon, and we in preparation of optical fiber, the sand is sand is important for sand is the most important ingredient for the preparation of optical fiber. As we know that the sand is present in a large amount in lithosphere, so we can get the sand anywhere. So it is the resource conservation. And the safety: when we use before 1840 or before discovery of the optical fibers, we can say we were using the copper wires, where the current can get the spark flash and short circuit would takes place in that case. Whereas in optical fibers there is no chance of sparks flash, so there is a high safety. Okay na? And security: whereas here the data is secured, there is no problem of security, and the data is secured in everything, and the unauthorized persons cannot access your data, so the data is secured. And low losses compared to copper cable. When you compare to copper cable, there is a much loss, because optical fibers obeys the laws of conservation of energy, means there is no fraction of loss also in energy, whereas in copper cable there is a loss of energy. So the loss of energy, there is a low losses. Temperature: the melting point of glass is much higher than the copper, so the glass is used for preparing the optical fiber instead of copper. Copper has the high melting point, so it can melt easily, and the short circuit, or we can say there is a chances of getting fire. And the long life: the life of glass fiber is predicted to exceed 100 years. Means if we do not expose it for any atmosphere, moisture, or for anything, then it can last for 100 years. Okay na? Then disadvantages of optical fiber: limited application. It has a limited applications. It has a limited application, means it can go through only for ground. It is applicable for only ground. and it is not applicable for mobile communications, and only for telecommunications and computer system we can use it. Whereas low power means it has a low power and we need the high amplifiers. Okay na? So we have the less power in optical fiber. And distance, we know that it is applicable for only shorter distance because it is applicable for only the ground. Okay na? Not in airways we cannot applicable, no? So, and next is applications of optical fibers in various industries. Communication. Optical fibers when used in communication is called as an optical communications, and we know that the electrical signals are converted into the digital signals, and the digital signals are again converted into the electrical signals. This process goes on between the transmitting antenna and receiving antenna. This is how the communication takes place. We know that. And next is pharmaceuticals, and the diagnosis of diagnosis, as I said, your optical fibers acts as a good sensors also. So, and optical fibers can sense the different parameters, that is temperature, pressure, voltage. So it can be usually used as a pharmaceutical, and it is also used in spectroscopy also, and biological and biomedical sciences also, as we know that it can sense the internal organ, it can sense different parameters. So we can say that it can also diagnose the internal organs of human body. And next is petrochemicals. As we can say that chemical energy is directly proportional to electrical energy. We know that we are using the mobile phones, which is made up, actually the battery is made up of chemicals, and that chemical energy is converted into electrical energy. So we can say that chemical energy is directly proportional to electrical energy, right? So that is also used for petrochemicals, and it is also used in food and beverage industries, means in preparation of food, like using the sensors. Okay. And beverage means drinks, it is also used for preparing the drinks. And plastic industry, as I said you, the optical fibers are mainly used in decoration purpose, so it is also used in plastic industry also. Then study of soil samples, because they are sensors, good sensors. So just understanding the basic chemical reactions. Next, the energy and military services. Last and but not least, energy and military services, because it is used in energy military services because it provides high safety. The unauthorized persons cannot access the data, so it can produce high security for the data. Last but not the least, that is thus optical fibers made our lifestyle more comfortable and compactable. That is, we can go hand in hand with optical fibers right now without copper cables. Thank you.